Okay, so welcome back, and now I'm going to talk about two other cases that comes out of the limit comparison test. So in the previous video we talked about the limit of the ratio going to some real number other than 0. So what if there's two other cases we could use the limit comparison test? And the first one is, what if the limit does go to 0? Well, what that implies is, it implies that the sequence of the ratio of the terms is bounded, okay? Because obviously the limit of this ratio, if it goes to 0, what we could say is it is bounded. And so what that means is that there exists a constant m such that a sub n is less than or equal to some multiple of b sub n, right? For all n greater than or equal to n. Okay? Now, what that means is, since this is always going to be less than or equal to some m, right? So, times b sub n, well, that means if b sub n converges, then so does the series of a sub n. Okay? So now, that's case one. What about if the limit doesn't exist? What if the limit goes to infinity? Well, that means that the sequence of the ratios, right, of the nth terms is unbounded. And so that means that for every constant m, there's going to exist an integer n such that a sub n is greater than or equal to the multiple of b sub n, right? So m times b sub n. So that means what? And that's true for all n greater than or equal to n. Okay? Now, what does it mean? It means, therefore, if this diverges, right? If the series of b sub n diverges, and we know that a sub n is greater than the multiple of that, then that means the series of a sub n also diverges. Okay? So those are the other two cases we want to consider. Okay, so the next video, or the next lecture, we'll talk about, we'll introduce the theorem for the limit comparison test. See you then.